All right, so today we're going to be looking at going from the name of an ionic compound that involves a transition metal and then figuring out the chemical formula it has. So starting off with here, if I just said copper chloride without making that mark there, copper chloride doesn't tell you a whole lot. We know copper is a transition metal. It's in that kind of D block of electrons. So we know that there's a chance it could have multiple charges. And so we check the polyatomic ion sheet and we see, yes, indeed, copper has more than one charge. So I know this name, probably not correct. Let's say that I'm working with the name. Thank you again, Flipboard. All right, so let's say we have copper 2 chloride. All right. So I need to go through and I need to figure out just how to write the formula for this. So I know starting off, copper has a symbol of Cu. The parentheses 2 tells me that it has a charge of positive 2. Chloride, I know, is Cl, and if I check the periodic table, it's in column 7, 7 outer shell electrons, closer to 8 than 0, takes an electron to get to 8, from the charge of -1. At this point, I wrote the charges. Now I just need to crisscross them. Pretty easy. So I would end up with 1 copper for 2 chlorines. From here, I know what the name is. Let's say instead of working with that, I'm working with iron that's combined with oxygen in this ratio of 2 to 3. So 2 irons for every 3 oxygens. Iron not in columns 1 or 2. It's in that D block of orbital, so I know iron is a transition metal. So it could probably have more than one charge. I checked the sheet. Yep, I have a couple options here. This is where we're going to have to do just a tiny bit of algebra. So I don't know what charge my iron has. I know it's going to be positive because the oxygen's negative. In fact, I can figure out what the negative charge on oxygen is. The quantity of the charge on a non-metal is locked in. So oxygen, 6 outer shell electrons, closer to 8, takes 2 electrons, charge of -2. All right, so in this case, oxygen has a charge of -2. I have 3 of those. So I actually have a total negative charge of -6. All right. So that means, like over here, if I'm kind of indicating this the same way, whatever the charge on the iron is, has to equal +6. Separate those two a little bit. So now I just have to do a little bit of math. So let's just call that, we have 2x equals +6. If I need to know what charge that iron has, since I have 2 atoms of it, I'm just going to take that +6 divided by 2, and I find out each iron has a charge of +3. And let's see how easy I can erase that. That's not bad. Okay. So each iron, we said, charge +3. The other way that you could do this that works most of the time is essentially you could reverse cross it. Like if we have the number of atoms down, write the atoms down low, crisscross them back up. That 3 tells me this charge of +3, that 2, -2 there. And then from here, once I know that the iron has a charge of +3, I can name this iron 3. Oxygen becomes oxide. So it's not bad. It's just a little wrinkle. It's not doing anything new or crazy. It's just making sure we're getting things named right. We're getting the right charges on these things. So if you just have the formula without any of the charges and figure out the name, you can do it algebraically, figure out what's your total negative charge from taking the number of non-metal atoms times the charge. Same thing's true for polyatomic ions. That gets you your total negative charge. Your positive charge has to equal it, because the whole reason why we formed these ionic compounds is to get to a net charge of 0. So here we have +6 and -6. That's 0. I hope that explains it pretty well. I know it was pretty quick and easy, but ionic bonding kind of is. All right, so with that, good luck with the practice.